What do you think? Is it true? What about this equality? Are they really equal? Who have idea? Let's check, okay? Let's check. Who check? Let's find what is dx square. Dx square, let's write down here, dx square, it's going to be derivative of x square multiplied by dx. It equals 2x dx. Now to compare left side and right side of these equalities, we can notice that there we missed coefficient, and this coefficient is 1/2. Please look carefully to realize it. And now I can continue. It equals 1/2, the same coefficient. And what can we say about this integral? In the power, we have x square, and also here we have x square. And we can imagine that this x square is, for example, t, and we can write down e to power x square plus c. Any questions?
I have a question.
Okay, Mariam.
Why is 1/2 here? Why did we write that?
Okay. Mariam, let's check this equality. I mean, this equality. Is it correct or no? Let's check, okay? If we will find dx square, I will write down here dx square. Dx square, it's derivative of x square times dx. So it's 2x times dx. Do you agree?
Yeah.
Now imagine to substitute this dx square, to substitute by this expression. We will get left side because we can move out 2 across integral sign, and 1/2 times 2, it will be 1, and we will get this side. Write down it in your paper, and I think it will be more clear and more easy to understand.
Understand.
Okay. Okay, let's do next example. And this example is this example is similar with previous example, and it's 3x e to power x square dx. 3x e to power x square dx. Now, please notice that x, this x, compare this x and this x. This x power is less by 1. Power of this x is 1 and power of this x is 2. And it's good idea, in this case, it's good idea to this x to move into differential. Because when x we move into differential, power of this variable will increase by 1. It's because of formula of power function. We remember derivative of power function x to power n, it's equal n times x to power n minus 1. So in other words, when we differentiate power function,
I can't hear you. I can't hear.
now,
Yeah.
okay. So let's recall derivative of power function. When we differentiate it means when we take derivative of power function, power of power function decreasing. For example, what is derivative of x square? Derivative of x square is 2x. Power of x, it was 2, and after differentiation, it's x. So it's good idea, it's hint to take this x into this differential. And let's do it. So it's, I will write down 3 e to power x square dx square. And now let's check. Are they equal? And how to check? We can find differential of x square, dx square. What is dx square? And dx square is 2 times x multiplied by dx. And that's why this left and right side to be equal, we need here coefficient 1/2. And now I will continue now. I can move out 3 because 3 also is constant, and into integral we have a function e to power x square dx square. Now notice that in the power of x of e we have x square, as well as into differential we have x square. And we can imagine that it's t, and I can write down that it equals 3/2 times e to power x square plus c. Any questions? Okay, if no questions, I have a question. And my question is, find integral e to power 3x dx. E to power 3x dx. Please start solving and I will follow you.
So we have to make dx into dx cube.
How, Luca? Say again.
Like we did before.
Okay, and how we did before?
Turn it into
So e to power 3x, and what is your idea what I should write here? D what?
x cube.
X cube. Okay, let's check, Luca.
But now it needs to divide, we have to divide it.
Divide by what?
1 second.
3.
And please take Luca's idea. Luca's idea is that to write down dx cube.
I divided by 3.
Okay, I will divide by 3. 1/3 I will write. Now check. Check, is it correct? Let's check. To check, I should find this one, dx cube. But what is this dx cube? It's derivative of x cube times dx. And what is derivative of x cube? Derivative of x
Or
3x square.
3x squared.
x square dx. So it looks that they are not equal.
Yes.
Because we have here extra x square. I think this 1/3, it's good. It's a good coefficient.
Yes,
We
but
have
it's
now
extra
here
x.
extra x square. Yes. Looks it is not good idea. Okay. What is other idea? What we can write down into dx? In fact, into dx, we need to write down not x cube. If I will write down there x cube, it's not help me to integrate it. What I need into dx is this exponent, this power 3x. Because in the power and into d, I will have the same expression. So let's try to write here 3x. And let's check now. Let's now check.
Oh, yes.
3x. What is this 3x? This 3x is derivative of 3x times dx. It's going to be 3 dx. And if I will replace by 3 dx, we will go to left side, absolutely the same. Is it clear?
Yes.
I can repeat.
Yes.
I can repeat over and over. If it is not clear for someone, do not hesitate and ask me. Now let's continue. Now we have in the both place here 3x and here into d into differential we have 3x. And it means we can imagine it as t, and we know very well integral e to power t dt is again e to power t. So it's going to be 1/3 coefficient e to power 3x plus c. Now check yourself. Check yourself, and I will give you similar example. Integral 2 times e to power 4x dx. Check yourself and solve independently this integral. Okay, I will follow you.
At first, we need to do it like integral 2e for x power multiplied by d for x, yeah?
Yes, I think it's a good idea. Into D, we need 4x. We need 4x to use formula for integration. Okay, and let's write 4x and then check. So,
And we have to divide it by 4.
Yes.
so I guess you want to write down here like this: 1/4 times 2, and this 2 is this constant, and I'm going to move out across integral sign e to power 4x times dx.
So it will be 1/2.
No, sorry, I missed 4. I want to write here 4x.
So it will be 1/2.
No, first of all, let's check. Is it proves this equality? Are they indeed equal? It's very important. It's very important to check. Are they equal or no?
Yes, they are.
Yes, they are equal, because if we will find p for x, we will get absolutely left side. So now let's continue. Here we have 1/2, and as for this integral, it will be e to power 4x and plus c. Okay, next similar example, it's integral e to power minus x dx.
Here we just need do the same, but negative, yeah, or how?
Okay, tell me what we should write down.
Minus.
E in power minus x, yeah, multiplied by d minus x.
Okay, let's try. So it's e to power minus x d minus x. Now let's check.
And I think we need 1 minus only.
We need
Yeah.
minus. Yes, yes, yes.
Because minus in derivative.
Okay. So now we can find its minus and then e to power minus x plus c. And one more example. Integral e to power minus 5x dx. Check yourself.
First, we need to do it like integral e in power minus 5x multiplied by a derivative of minus 5x, yeah? And this,
Not derivative. I guess you mean d.
it's a d, yeah, multiplied by.
So you think I should write down e to power minus 5x d minus 5x.
And a derivative like minus 1/5 or
Coefficient. Do you mean
But will it work for negatives as well?
yes.
And now we need here, I think we need here coefficient. What coefficient? Minus 1/5. Do you agree?
Yes, I do. I think it's correct. Now I just finish this example.
So let's continue. It's going to be minus 1/5 e to power minus 5x plus c.
Yes.
Okay, next example. Let's give next example and find integral. Integral dx over x plus 5. We don't have this integral in table of basic integrals. In basic integrals,
Here we have some formulas, yeah, or how?
in basic integrals, we have formula, but without 5. We have formula integral dx over x. Do you remember what is it? It's basic formula.
ln x.
Yes, it's ln x. We have this formula. But now how can we use this formula? They are similar, and I suppose that we need to use this formula.
Like x plus 5 is equal to t maybe, and
Okay, let's try to write down dx plus 5 and here x plus 5.
Huh?
What do you think about this equality? What can you say about this equality? Is it true or false?
Yes.
Yes. Let's check. What is dx plus 5? Dx plus 5 is going to be derivative of x plus 5 times dx. And what is derivative of x plus 5? Derivative of x plus 5, it's 1, because derivative of x, it's 1, and derivative of 5, it's 0. So it's going to be dx. So we got that this dx, they are equal. Dx equals dx plus 5. And that's why these two integrals, I think they are really equal. Now, we can imagine that this x plus 5 is t, and we have integral dt over t. It's basic integral, and it's going to be ln x plus 5 plus c. Any questions?
No.
Okay, if no questions, now check yourself. Check yourself and find integral. Dx over x minus 1. I will follow you now. I think
ln x minus 1.
There will be x minus 1 plus c.
x minus 1, and it's going to be ln x minus 1 plus c. Okay, now let's make it more complicated and find integral dx over 2x plus 7.
ln 2x plus 7 over 2.
Maybe. But let's first
Plus
replace dx by d 2x plus 7. 2x plus 7. And we can notice that to be equal, there we need
Should add 1 over
coefficient.
2.
We need the coefficient 1 over 2. And if we will continue, it's going to be 1 over 2 ln 2x plus 7 and plus c. Any questions?
Why there 1 over 2? Where from?
Okay, very good question. Let's check. My answer always is to let's check. So d2x plus 7. It's by definition it's 2x plus 7 derivative dx. It equals, what is derivative of 2x plus 7? Derivative of 2x, it's 2, and derivative of 7, it's 0. That's why this derivative is 2, and we should multiply 2 by dx. So this differential, d2x plus 7, this differential, d2x plus 7, it's 2 times dx. And if I will plug here 2 times dx, we will get left side. So to make sure that equality is true, always good idea to simplify differential and then compare with left side.
Yes. Okay, I got it. Yes, but where is c? We need to write like 2x plus 7, close the bracket, or what? And plus c, yeah?
Yes, plus c. Plus c, we need it always when we have indefinite integral. Okay, let's one more example. One more example, it's integral dx 5x plus 7. So it's instead dx, I will write down d 5x plus 7. And here 5x plus 7.
It needs 1/5.
Yes, we need here 1/5. 1/5, and it equals 1/5 ln 5x plus 7 and plus c. Any questions?
No question.
Okay, let's give last example. And this example is integral x squared plus 1 dx. Any idea?
Here we're gonna like multiply x to dx, yeah, by dx.
X I think here good thing.
Times x squared plus 1.
I think here good, yes. I think here good thing is that power of this x is less than power of this x, and it's less by 1. And it's hint for me to try to write down dx squared plus 1 x squared plus 1. And now let's check. Let's check. And how can we check? We can find it. Dx squared plus 1 is going to be x squared plus 1 derivative multiply dx. It equals derivative of x squared plus 1. Derivative of x squared is 2x. Derivative of 1, 0. So here we have 2 times x dx. 2 times x dx, it's dx squared plus 1. But now if I will compare with left side, we can notice that we miss coefficient. And what is this coefficient? I think this coefficient is 1/2. Now check. Check now again. Do we have equality? Is this equality true or it's false? So as we told, dx squared plus 1, it's 2x dx. And now imagine that instead of dx squared plus 1, we have 2 times x dx. These two and these two, they will cancel, and we will have exactly left side. confirm, please, if you agree.
It's true.
So let's now continue. Let's now continue. Dx square plus 1, dx square plus 1, and in the denominator, I have the same, x square plus 1. So what can I write down? What will be this integral? It's ln x square plus 1 plus c. Because x square plus 1, we can make it as t. So we have here integral dt over t. And this is ln t, absolute value. But here I can not write absolute value because x square plus 1 is look carefully if any questions. Ask please if any questions.